Find dy dx of the equation x squared minus y squared equals 4. So using implicit differentiation, we're going to take the derivative of each of these. So derivative of 2x is, derivative of x squared is just 2x. Minus derivative of y squared. Y is not explicitly given here. So first we take the derivative of y by the power rule, thinking is outside function, multiply by dy dx by chain rule. And derivative of 4 is just 0. So now what we need to do is solve for dy dx. When we solve for dy dx, all the terms with dy dx should stay one side of the equation. Everything else should stay in the other side of the equation. So here actually I'm going to add this both sides. So then we have 2x on the left side. On the right side I have 2y adding, so 2y times dy dx. Then we need to solve for dy dx. Therefore, we divide by 2y. So then dy dx equals 2x over 2y, which simplifies to x over y. Find dy dx of the equation 6x squared plus 3y squared equals 12. So using implicit differentiation, we're going to take derivative of these and solve for dy dx in the end. So here, just simple power rule, derivative of 6x squared is 12x plus, for this one we have to use chain rule. So first 2 times 3 gives us 6y multiply by dy dx by the chain rule equals derivative of 12 is 0. So once you come this far, all the equation, on the equation, all the terms with dy dx should stay in the one side of the equation. Everything else should be in the other side of the equation. So we have two choices. We can subtract 12x both sides, or we can subtract 6y dy dx both sides. Both of them will give us the same answer. So here I'm going to just to subtract 12x both sides. So then I get 6y dy dx equals 12x. Or it'll be negative 12x, right? Negative 12x, since I'm subtracting 12x. So then I need to isolate dy dx here, since we're solving for the derivative. So we divide by 6y both sides. So then dy dx equals negative 12x over 6y, which simplifies to negative 2 over negative 2x over y. Final answer. Find dy dx of the equation x squared times y equals y minus 7. So here, for this portion derivative, we need to use the product rule, since two functions or two equations are multiplied. So let's keep that in mind. So when we take the derivative of x squared, which is 2x times the second function y plus derivative of y, which is dy dx, multiply by x squared, equals derivative of y is dy dx, since we're taking derivative with respect to x, and derivative of 7 is 0. So once we come this far, we're going to solve for dy dx. When we solve for dy dx, all the terms with dy dx should stay in one side of the equation, and everything else should be in the other side of the equation. So here we can subtract this both sides first. So I have 2xy equals dy dx minus dy dx times x squared. So I subtract this both sides. So then, again, our goal is to solve for dy dx. So here I'm going to factor dy dx out. So I'll factor dy dx on the right side of the equation. Then I get 1 minus x squared. The left side is just 2 times xy. So for the final answer, we need to, again, isolate dy dx. That means we're going to divide by this both sides. So let me write the final answer right here. dy dx equals 2xy over 1 minus x squared. So this is the derivative of y with respect to x. Find dy dx of the equation 3x to the third power plus 9xy squared equals 5x to the third power. So here, remember for this portion, we need to use the product rule when we take the derivative. So let's keep that in mind. So derivative of 3x to the third respect to x is just 9x squared plus derivative of this portion, we need to use product rule. So let's think as 9x times y to the second power, first function and second function, or f as 9x and y squared as gx. Okay, so 9x is the first equation, y squared is the second equation. So derivative of 9x is 9 times second equation, y squared, plus derivative of y squared is 2y dy dx by the chain rule. Multiply by, don't forget this part, 9x. We have to multiply the first function or first equation. Equals derivative of 5x to the third power with respect to x is just 15x squared by the power rule. Now, what we have to do is we have to solve for dy dx. That means all the terms with dy dx should be in the one side of the equation. Everything else should be in the other side of the equation. So in this case, we can subtract this both sides. So I'm going to subtract this entire thing both sides. So let me write that in the next line. So 9x squared plus 9y squared equals 15x squared minus 2y times dy dx times 9x. And then we're also going to subtract this thing both sides so we can have the term with dy dx by itself on the one side of the equation. In this case, right side of the equation. So here we have 9x squared plus 9y to the second power minus 15x squared equals, let's actually multiply these out. So we have 18 xy times dy dx. So now, again, our goal is to find dy dx. So we need to solve for dy dx by dividing by 18xy both sides. So the final answer, let me write it right here, the entire step. dy dx equals this equation divided by this. So 9x squared plus 9y squared minus 15x squared divided by 18xy. We can actually collect like terms here. I didn't see that earlier, but that will give us negative 6x squared plus 9y squared over 18xy. So this is the derivative of y with respect to x. This right here. Find dy dx of the curve yx minus cosine xy equals 1. So here we have to use product rule here when we take the derivative. Here we have to use chain rule. Within the chain rule, we also have to use product. We have to use chain rule. Within the chain rule, for inside function, we have to use product rule. Okay, so let's do one step at a time. Let's do this one first. Derivative of xy is x. Derivative of x is 1 times y plus derivative of y is dy dx times x minus, let's take the derivative of cosine xy. So let's keep the parentheses. Well, derivative of cosine is negative sign. So when we write negative sign keep the argument here, or the inside is xy. Then we need to multiply by derivative of inside, derivative of argument xy. So let's do this. So we can do step by step. And this entire thing equals, well, derivative of 1 is 0. So next line, I'm just going to copy this portion. dy dx times x minus negative. So let's make it positive. Positive sine xy. Now let's take the derivative of this portion right here. We have to use product rule. So derivative of x, multiplying, so when we keep open the parenthesis, derivative of x is 1 times y, plus derivative of y is dy dx times x. Entire thing equals 0. Get our goal now. We're done taking the derivative. Now we need to solve for dy dx right here. So in order to do that, first we actually have to distribute sine xy to here and also here. So the next line, that's what I'm going to do. So we have y plus dy dx. Let me actually use different color. Y plus dy dx times x plus sine xy times y plus sine xy times dy dx times x equals 0. So now we need to keep all the term with dy dx in the one side of the equation, everything else in the other side of the equation. So y right here and sine xy times y, I'm going to subtract those two, this and this, both sides. So I can have dy dx terms, which are these two on the one side of the equation, left side of the equation, equal sign, everything else in the other side of the equal sign. So we have dy dx times x plus sine xy times dy dx times x equals, subtract this both sides, so we get negative y. Subtract this both sides, we get negative sine xy times y. So then we need to isolate dy dx, therefore we need to factor dy dx here. Dy dx, we have x plus sine xy times x. Don't forget this x right here. Entire thing equals negative y, negative sine xy times y. So finally, in order to solve for dy dx, we need to divide both sides by this right here. So let me write the final answer right here. Well, dy dx equals x plus sine xy times x over this expression right here, negative y minus sine xy times y. So this right here is the derivative of y with respect to x. Find dy dx of the equation y times square root of x plus 4 equals x times y plus 8. So for this one, first we're actually going to write this square root as half power. Like this, equals xy plus 8. Now we're going to take the derivative. For this one, we need to use the product rule. So derivative of y is dy dx times x plus 4 to the half power plus derivative of x plus 4 to the half power will be using power rule, half x plus 4, subtract 1, so we have negative half on the exponent and multiply by y equals derivative of xy using product rule here also. Derivative of x is 1 times y plus derivative of y is dy dx times x. And derivative of 8 is 0. So we don't need to write anything. Now what we have to do is we have to solve for dy dx. So all the terms with dy dx should go in one side of the equation. Everything else should be the other side of the equation. So what we do is let's subtract this both sides. So we have dy dx x plus 4 half power minus dy dx times x. So I subtract this both sides. And on the other side, I'm actually going to subtract this both sides. So equals, where's y, minus this both sides. So this will go away from the left side, only stays on the right side. Half. We can actually rewrite this as half times 1 over x to the half power times y. So now what we need to do is we need to factor this dy dx here, so we can isolate dy dx. So let's factor dy dx. Then we get the inside of parentheses, we get x. We can rewrite to square root now, minus x, because we rewrote it half power, so we're going to apply the power rule. Now that we took the derivative, we can rewrite back to square root equals y minus this one. We can also rewrite it to square root, so we have y multiplied to numerator, y over 2 times square root of x plus 4. So for the final answer, we need to divide both sides by this, so we can isolate dy dx. So let me write the final answer here. So from here, dy dx equals y minus y over 2 times x plus 4, this entire thing is the numerator, divide by square root of x plus 4 minus x. So this right here is the derivative of y respect to x. Find dy dx of the equation negative xy minus 2 equals x over 7. So first here we need to apply the product rule when we take the derivative. We can think as negative x times y. So derivative of negative x is negative 1 times y for the product rule, plus derivative of y is dy dx using chain rule. Well, not chain rule here, but product rule by the product rule. Still in process product rule, plus we'll multiply by negative x. Derivative of 2 is 0. Here we have x over 7 is same as 1 over 7 times x. So derivative of that is just 1 over 7. So our goal is to solve for dy dx here. So let's add y both sides. So we have dy dx times negative x equals 1 over 7 plus y. And then we need to solve for dy dx. So I'm going to multiply by both sides by 1 over negative x. So dy dx equals negative 1 over x times in parentheses plus y. So we could distribute this. So then dy dx equals negative 1 over 7x minus y over x. So this right here is the derivative of y respect to x. Find dy dx of xy second power plus 3x equals y squared. So here this actually means x squared y squared plus 3x equals y squared. So for the first portion, when we take the derivative, we need to use the product rule. So derivative of x squared is 2x times y squared plus derivative of y squared is 2y dy dx times x squared plus derivative of 3x is 3, derivative of y squared is 2y dy dx. Now all the terms with dy dx should be in the one side of the equation. Everything else should be in the other side of the equation. So here I'm actually going to subtract this both sides so that it's probably a little faster we subtract this both sides. Either way will give us the same answer. So let's do that. 2y dy dx minus this thing. 2y dy dx x squared. So here we need to isolate dy dx. I'm going to factor dy dx on the right side of the equation. Dy dx 2y minus 2y x squared. So for final answer, we need to divide both sides by this so that we can isolate dy dx. So let me write the final answer right here. Dy dx equals 2xy squared plus 3 over 2y minus 2y x squared. So this is the derivative of y with respect to x.